I'll go on here. Okay, so number 9. Yeah. Chapter 7, number 9. What we got? What we got? Chapter 7, there's no number 9. Oh, on the review?
Yes.
Okay. Rank size rule. According to the rank size rule, if the largest city in an economy has a population of 12 million, the fourth largest population, or the fourth largest city has a population of what? What was the answer? 3.
I got 1.5.
You thought 1.5? Okay, how'd you get that?
It's the next largest city, half the size.
So the rank size rule is applying basically it ends up being 1 over the rank. So the fourth size city, I don't have my thing pulled up here, but what was you guys got a formula as part of your arguments?
It's like R equals C M B squared.
Yeah, this was B, was it what?
It's M and B squared.
N and then to the B power. And B equals 1, by the way, is what we tested. So if B equals 1, then it's just this. And so the rank is if you're fourth ranked or whatever, and N is the population, then we've got that constant C. Let me why I didn't pull up my slides. So you were taking half of half of half. So it was always the rank number is the factor. So if this is n equals, and it's n to the 1 equals C divided by R. And the constant is the part with the population. So if it was the second city, let's see, so a rank of 2 and a population of, n is the population of the largest city, right? Oh, wait, hold on, let me pull it up. Sorry, I messed it up. I guess I could just pull it in the book here too. Here's from the couple pages into the book. All right, so that was the C over N to the B. If B is 1, the rank size rule holds. The example shown in figure 7 is consistent with the rank size rule. C equals 12 million and B equals 1. The largest city of the population 12 is followed by a city with 6 million. So that's always just rank 1 is the population divided by it. The constant is the largest city's population. So then it's always 12 divided by 6 for the second ranked city. 12 divided by 4 equals 3. So in flipping that around, it's just the 1. It's 1 divided by 4.
Is that not the third ranked city? It's asking for the fourth.
So the fourth ranked city. So if we take the let's take this. Well, let's just start. Let's start here. It's just as easy. So the rank of the second size city, so we've got rank equals 12 million, which is the biggest, and this is the population of the current city. And so this was the rank 2, right? So which equals 2.
How do you get this 6 million?
So now, yeah, that's what I'm going to do here. So the 12, so basically how this thing always solves is that this rank just switches over here. So doing a little bit of algebra with this, we get the population of the biggest city divided by the rank equals the population of that city. And that's all it's doing each time. So here, the third city is 12 divided by 3 equals 4. So you're solving for the rank to get back to this question. If you're looking for the fourth largest city, then you're just going to take the 12 million divided by 4 equals 3 million. You're solving for the population of the city. So you're just doing the flipping the numbers around. Okay, good. Yeah, James. One apply. So car planes, city size, consider a regional city with 12 million workers, urban utility curve of that, where it ends the number of workers. Initially, the region has 4 cities, A, B, C, and D, each with 3 million, so grand total of 12 again. What the equilibrium utility level is. And so what part of this was your question?
I'll leave
B. Okay, so what was the answer for A? Anybody?
33.
33. Okay, so we had 33 for A. And how'd you get that?
7, 3 for N, and then work out the equation.
7, 3 for N. Okay, so 3 and 3, you're doing 3 because they're equally distributed among there. And so that's our starting utility, okay? Suppose the city introduces city A does car planes to replace regular cars for commuting, so we've got to shift up presumably here. Predict the effect on car plane equilibrium distribution population within cities and the regional and those. Okay, so now 12 inch. Oh, okay, so they just left it generic. They didn't tell you like we did that other problem with how much it went up. Okay, so what'd you guys get? Awesome.
I assumed that all 12 million workers were going to go to the city with the car planes because of the easy transport, and then I just put that in the equation to get the utility for the team.
It shows you, it gives you a different equation to solve your utility. Now, in city A, it's different from B, C, and D.
In the answer?
No, in the question, because your second formula is for A, and the one in the original question was the original.
Oh, I see. There is a difference. Yeah, the two. I didn't catch the 2. Okay, I didn't catch
That's
that.
how you could solve.
Yeah. So then you can. And so what you do? Set them equal to each other?
You just have to work it out.
Plug in
Or did you
12
just plug and shut?
Well, you put in the 12 million in for that new function because everyone's going to be going and working there. It's the assumption.
Right. So we can start statically and say the population with 3 of the new function. So let the new 3 with the I don't know what I call it, car planes, whatever. Let's just say the new. And what do you guys get for utility when you plug it in here? 51. Okay, so Jameson, you cool with that, or? Yeah. Okay, so then where did you go from here? Or what's your question from that part?
Like the regional.
How it redistributes? Yeah. Okay, so what did you guys do from here? So now we have the other ones are at 33, right? And now this one community has the 3 million people. All right, so what did you guys do?
It told us that all 12 million were going to go to A.
All 12 million are going to go to A, is what the answer you gave you. Okay.
And then I just plugged 12 in for N, and it gave us the utility of 50.
So 12 into here gave you utility of
15,
15, okay.
which was also unanswered.
Yeah, that seems a little unusual, but maybe it's something's going on there. So what happens when you reduce, what side of the curve are we on with the initial condition? How do you know?
Population decreases.
Okay, so how did you prove that to yourself? So what I heard you guys say is that at 3, you were at 33, correct?
Yeah, and then I just plugged in 4.
So you went one
I went
more.
one more, I did the opposite.
Okay. So one more, and what'd you get?
Like, I got, let's see, I got 31.
31, okay. So that would prove that you're on the downward slope, right? That we're not on the upslope like we were with that other problem. Is that clear?
Yeah.
Okay.
That's for me.
So now, when you do leave down to 2, what happens? Because now I'm thinking people are heading over to 51, right? Did nobody do this?
I got 35.
I mean, I think this would be kind of a good exercise to do to see if you needed to show me in your papers that they actually all went to,
Well,
that the answer key was right. I mean, I want to make sure that that happened.
it was harder to show that if the other 3 cities are equally distributed. Do it like in groups, because you have to do it in like multiple. So if you had like 9 in city A and 1 in each of the other.
If they all took 1 and then you bumped up by 3. But you could do it that way, but let's just say 1 goes. So what did happen here? Somebody calculated it? 35. So this goes up to 35, but now that extra 1 here, what happens here? Because now this one has 4 with the new. If we take 1 away from these guys and put 1 over there, what is the new? 27. That was a pretty big drop if that's the case.
47.
47. Okay, that sounds, did other people get 47? Let's just double check the work. I don't have an answer for you guys, so let's just double check the work here.
Yeah, it's 47.
47, okay, so we lost 4. So now think about what's going on with the slopes like we did before. We were at 3 and we gained 2, right? So there was a +2 here. For the people who left, the remaining people, they gained 2. But then when they come over here, this dropped to 47, so that was a drop of 4. So we kind of got that thing going on. We don't know when this thing peaks. That might be kind of interesting too. What if we do go down to 1? What's that answer? It looks like we got a parabola here, not a straight line like we did before.
25
25 at 1?
for the original equation is 25.
25.
Where did 51 come from? You started at 33 though.
Yeah, we started at 33 right here. I just want to make sure we're trying to get the shape of this thing. So we started here. This is with the any one of the original with the original function. So this is really the u of n old, right? And so we said we went +2 to 35, but then if you drop down to 1, it went to what?
25.
25. So that's 25 down here. So somewhere between 1 and 2 it peaks, right? Or does it peak at, what does it do at 1.5? That's one way we can start to see if it actually peaked at 2 or if it peaks somewhere in between. What's 1.5? Says 28.5. Okay, so I suspect 2 is probably the optimal if that's coming in 28. So the real growth curve does not look like this, but it kind of looks like it does something like this. What is it at 0? That's kind of fun. 15. So nobody's there, but yet there's somebody enjoying utility. This is one of the things, that so we get to, but especially with the 15. But all right, so 1 with that was 25. So it's something like this. Right? If we were to draw it, just kind of plugging a few numbers to get the shape of it. And then you could test to see if it was actually peaking there or not, but we don't really need that for this problem. Okay, and then we got this going down to 47. And then where did this end up going to? 15?
Yeah.
Huh. All right. So, well, let's see what happened. So we did our 2. So what was the utility at 5? It should be less. Oh, well, not necessarily, I guess. If it went.
Where was it? You want? I guess I was.
There's 50.
Yeah, I think
It's 42.
It does go back up.
no, the 51 is actually.
Yeah, 51 is.
Oh, this is a screwed up.
Yes. I can see that.
42. Okay, so we can start. Get a little bit of. Okay. So with the old, we got 1, 2. 1, 2, 3. We were at 51. No, you guys just corrected that. 42. Right? All right, so we're at 42. And then at 4, it's 47.
Yep.
And at 5, 50. And at 6, 1. And at 7, back to 50. All right, so we peaked at 51. What's up here somewhere? I was starting to get up. 4 was 47. Now I didn't really drop the scale. We got something starting to look like that, right? Okay. So is it going to be sustainable once we keep going? So 8. Oh, let's just wrap it up. Not that far. It's 12. Everybody pick a number and solve for it. Tell me what you get.
847, 942.
Had you already done this before? 942.
Yeah.
Okay. Sam? 35. Over here.
26.
26.
12.
And 12 is 15. Okay. Now with 1 million, so if we were all at 12, would we have kept going that direction? I guess is always the big question. And so I'm thinking that the author had each city moving 1 per time, maybe, which is a bit of I think an assumption that's not necessarily out there obvious. So if we go chunking 1 at a time, we get happier. And then by the time we get to 1, we're at 26. And at that point, we have 2, 4, 6. We're 6 to the good from the 3 we were at. We were at 9, which is still 42, right? So then if you're doing it in chunks, that 1 goes each time, then we get to that 15. So I'm not sure I like that conclusion. Can we be more exotic with it if we relax that?
How does that look like?
That's what it seems like. If they're all identical, it's an economic model, right? So they have incentive. Each of the 3 remaining cities has the same incentive. So if 1 moves, the other one's going to move, because it's just an economic model. But if we allow there to be some sort of time variant, like let's say, it gets into a sequential game for game theory, right? If city B gets to move first, and then city C gets to see what B did, and then make their move. If we turn it into a sequential game, if we get into game theory, then we might be able to tell a different story, right? So if one city keeps exhausting themselves, and so here, when this city gets down to 25, there's still room up here for them to go, and this city disappears, but the other city stays at their level, right? Then we might get to a different solution. I don't think we really have to do that to this problem, because it does make sense from a game theory standpoint with the model that they all make these moves at the same time. Okay. We beat that one to death. Anything else, Jameson? Did that help? Okay. Any other problems on this problem set?
5.
Number 5. All right, air pollution and economic decline. Consider two city A and B, regional economy where each city operates on the negatively sloped portion of the utility curve. In the initial equilibrium, the two cities are identical. Then air pollution, lead emissions. Oh, in city B decreases the brain power, they get stupid, and the productivity of workers by 20%. Illustrate the effect of lead emissions on the regional equilibrium, indicating the direction of the change. All right, so what do you guys have for this one? Anybody got a nice picture they want to be proud of and come up and show? This one looks like it's right for a nice picture.
I mean, I just didn't have anything to scale it.
Okay. Yeah, there's nothing, I mean, there's not enough room. It's just gonna be a generic picture. So you want me to put yours up, or what was your question about the problem then?
I was just making sure like I didn't get something off because there wasn't anything to scale it.
Okay, was there even an answer provided, or?
Yeah.
What did it say?
A grows and utility decreases, and then B shrinks and utility decreases.
Okay. So yeah, you could use a little more meat on the bones here. What I'd like to see in a problem like this is similar to what we had in the overheads, with arrows kind of directing. We had that one where it shows the redistribution. So I will edit yours with your permission. Yeah, awesome. Maybe I should, you got a pen or a pencil around it? Just in case that's. All right, so this was your initial equilibrium, right? So they're all the same. And so we can think of it being here, that this is point A, but then this city goes to B. Now, I guess I got a problem with even where I drew this. What other information was in the problem? That's why I asked for pencils. Why you guys need to use pencils.
20% decrease in productivity.
Yeah, there's something else though.
Each city operates in a negative slope.
Yes. Notice how my eyeball conveniently went to the maximum. That's not where this problem says it is. It's on the negatively sloped portion. So somewhere over here, any of the negatively sloped portions will work, but A and B, or maybe let's do X and Y here. So point X and point Y. And so now what's going to happen? Who goes where?
People in B or to A.
Yeah, people in B are going to leave. So here's how I'd like you to show the leaving, right? So you kind of are moving away from that one. And then you can kind of cheat because you know what's going to happen in equilibrium. They're going to be the same. So you can kind of cheat a little bit. You have to bring what Lawson had down here a little bit, but let's just pick any old point in between. And then that'll be the new utility level. I still wanted to be on the negative slope here, so that's why I'm making this a little ugly. But so this would be utility level 2. And so this city will shrink to PB, population B, and this city will grow to PA. All right, because as these guys get more congested, their utility falls, these guys go up. That's how you'd want to show that graphically, which you might have to do on Friday.
But
Jonathan.
it says that as B shrinks, it still decreases in utility. It says that on
In the problem?
on the answer key.
Oh, on the answer key. Well, we don't put much faith in that.
Yeah.
But no, that's what, I guess read me exactly what the answer says.
It says A grows and utility decreases, comma, B shrinks and utility decreases.
Oh, you know what they're probably highlighting? I'll let Tyler, you want to speak to
No,
that?
you're good. I was just gonna say, I assume that it was because of the 20%.
Yeah, I think for the initial decrease, yeah. So here we have it, they're both at, they both start, let me work from this graph here. So they're both currently at this level. Let's just call it E for lack of a better word, lacking a letter. They're both here, and now this guy shrinks, right? So now we get this down to here. And so now they're going to be somewhere in between. And so these guys are going to shrink, and these guys are going to go. So you're right, Jonathan, that it's going up relative to X, but it's down relative to where they were when the problem started. Okay? Anything else on that one? Okay, any other problems? So I would say make sure you could draw what I just did. If you didn't put that down in your notes, make sure you got it. Yes. Oh, you wanted to do something? He was raising his hand, but okay, number 7. All right, so it looks like it's right here. Capital City Circus, consider a nation with a fixed population of 12 that's initially divided between 2 cities, Circusville and Dullsville. The urban utility curve is that. Suppose a dictator in Circusville initiates free circuses financed by coercive transfer payments from people outside the region. From people outside the region, okay. The circus program initially increases utility of living in Circusville by 3 units. Illustrate the effects of the circuses on the regional economy, including the values for city sizes and regional utility. Suppose that a dictator in Circusville initiates free circus. So who's paying for the finance?
Nobody important.
The people in
Those?
Dullsville, right? Consider a nation with a fixed population, initially divided between 2 cities. That is the urban. Now a dictator comes in, free circuses financed by coercive payments from people outside the region, which I'm thinking, well, I guess we'll see what the answer key did, but the circus program initially increases the utility of Circusville and then illustrate the effects. What did you guys do? What was the answer key, I guess, first?
Circusville equals 12 million, and then utility goes from 51 to 18.
Okay, Circusville 12, which is the whole population.
Yeah.
So Circusville goes to 12 million and what?
Utility goes from 51 to 18.
Okay. So working with those answers, what did you guys do?
I assume that all people want to move to Circusville so that they have their rewards not have to pay for them. So I plugged in 12 million to that equation there to get the utility compared to.
Okay. And so that gave these numbers, I assume. 18. Yes, 12. Plugging what?
Yeah, but you have to change the 15 to 18 because it's the plus 3.
Yeah.
Yeah. So this one is that they're shifting the sucker up by that constant. So graphically, if this was 15, 15, and now it's 8. All right, and so do we lose everybody? I guess that's the big question. So everybody, did you guys do the incremental shifts? So what was the initial Fixed population of 12 divided equally. So what was utility of 6? Did anybody do that?
I'm thinking 51.
How much?
51.
51. Utility of 6 is 51. Okay, and so what's the, if we're leaving this city, what's the utility of 5? Anybody do that? If you haven't, do it.
Should I get 51 still, or is it 54?
I'm leaving, I'm assuming that Dullsville, I'm doing the Dullsville one. I'm leaving Dullsville and I'm gonna go to Surfaceville.
It's 15.
So from the, so this is the old, basically, the old situation, or it's Dullsville. Dullsville didn't get the bump, so this is Dulls. How much?
It's at 50.
50, so they just lost 1. Everybody get that? Okay. And then what's the utility of Circusville at 6 with the new utility curve is what? Should just be now 54. And then what is it with 7? 50? Because remember, we're adding to Circusville.
Yeah.
So this is how much? 50?
50.
So it goes down. So now we're tied, interestingly enough.
So what's that? That would be what? No, what's that?
Now, are we on the downward slope or not? Let's test that. Let's go ahead and do, well, first of all, remember from here, we lost somebody and utility went down. So we're on the upward slope of this one. Let's just do utility of 4 for Dullsville. And then utility of 8 for Circusville.
47.
47 for Dullsville? So it went down again. And Circus with the 8.
Are you adding the 3? Because we're doing.
You gotta add the 3, yes. We're talking about the new,
Oh,
you're not,
Which means the
the
previous,
new utility.
the previous one should be 53, this
Yeah.
one's down to 50.
This one should have been 53?
Yes.
Yeah, this is with the new situation or Circusville. And then this is just 52?
50.
50.
Oh, it dropped to 50, okay.
Oh, we have.
All right, so now that still made sense then with the move, right? And so now we start to cascade. But you have to see that going first, so we're at 53 and 50, well then they still want to come, they drop to 50, but then these guys are at 47. Now we're on the down slope and it's gone, right? The city's gonna bust. And so that's where we get the conclusion of the flow. Or okay. The other city I left when you guys were doing these, that was at the old equation. And then these were at the new +3 equation, so 18 plus 12. That's what these were. So basically, this was the Dullsville, and this was the Circusville after with the switch of the 18. And so then what we ended up concluding here is that these guys were going to collapse down, and these guys were still on the downward slope, right? So they were on the downward slope, but always staying higher than these guys. So then it would go to the equilibrium would be at 12 and 18. Any other ones on this chapter 7? Yeah.
But like real life, wherever it's time where that doesn't happen, say wherever it's at 6 and 6 or something where it's that hot, they're in a situation like that, would it ever stop higher than everybody moving to the one city because people realize that hey, my utilities can be higher staying here even though that city has be better off.
I mean, so basically the moral of this story is just that people are going to go where they're going to be the happiest. And so when we try to address the question of why do some cities shrink, it's possible that the other city always has something more appealing. Now, in reality, people are different, preferences are different. I don't like people, you like people, I don't, whatever. We got all of the nuances so that a shrinking city will probably only shrink to it's not going to completely disappear in reality because of different preferences. So this model doesn't show any of that, but at least gives us a baseline conceptually to think the direction it could do. And the other thing that is, I think, insightful for this is that one city's policy change, or remember we had the innovation, ends up raising the boat for all of the cities. So when we had a positive jump up, then the utility of the city that didn't have the jump also went up through migration because of losing congestion or whatever. And then this example we just did on the pollution, all the cities lost, even though the pollution only impacted one city. So that's what the model kind of brings out and highlights for us. Okay, anything else? All righty, so chapter 8. So I sent you guys out a email announcement on Blackboard that'll be sitting in your email and also posted on Blackboard as usual, that the homework for chapter 8, back of the chapter, will be due Thursday before class, and your test is going to be chapters 1 through 8. And so we'll have some time on Thursday, we'll review, and then your test will be Friday when I'm in New Orleans. Did I mention that part? Okay, Jameson.
Why did they cancel classes on Thursday?
Oh, we'll cross the bridge when we get to it. Yeah. We'll probably,
We're at 8 to 12 inches.
we'll probably do a, see, I'm from Minnesota, so that's like nothing.
Yeah, but Kansas is weird.
I know Kansas, I've lived there for 10 years.
Auto roads.
Yeah, yeah. So we'll cross that bridge when we get to it. We might do a Zoom, and just hold it that way.
Okay.
So that you guys should plan on Friday for sure for the test. So start preparing yourselves mentally, physically, and otherwise. That don't expect to get a snow day, free day, because I don't think that's going to happen on Friday. But you never know. It's the weather. If it happened on Friday, then of course we would reschedule. But otherwise, we will definitely do Friday. Okay. Anything else? All right. So we talked about elasticity. Have a little bit of practice again with doing that. So just a little review. I think this is part where we left off last time. So we have an upward sloping supply curve. Remember that the supply of labor is people deciding on whether they want to work or not, right? The demand for labor, which we're going to get into in a little bit, the demand for labor, which Jonathan was wondering what these golf clubs are for, the demand for labor is businesses, right? Businesses that want to buy labor, and so they might increase their demand for labor, which will put upward pressure on wages, or they might see a fall in labor if their business goes overseas and they start outsourcing or something. We might lose demand for labor. All right, so we ran through that last time, and I think we did this too, right? Yeah, I think this is where we left off. So we'll just review it real quick. So this is the demand curve now. So we switched over to the properties of the demand curve. And we're basically saying, why does it have its negative slope? And so part of that is the demand curve being a derived demand curve. It was one of the last concepts I gave you. So if we think about the demand for labor, which is what we're looking at, this is the wage. And give me a good, any good, any good. Pizza. All right. So now we've got a pizza market down here. And there's a demand for our pizza, which looks like whatever it looks like. Okay. So why is the demand curve downward sloping? So why would we move from on the labor market curve from point A to point B? So the substitution says an increase in the wage, firms will substitute other inputs for relatively expensive labor. Now, that's an assumption that we've made in some of these models, that we say they have to be in fixed proportions, right? So it's always 80% machine, 20% labor, and we don't substitute. So if that means if wages get more expensive, too bad. You're still gonna hire the same amount of people. That's an unrealistic assumption though, right? So that's what the substitution effect is saying, is that if we move, and I guess it says an increase in the wage, so let me reverse this to A and B. So an increase in the wage. We used to be able to get people for $10 an hour, and now it's $15 an hour. And so we're gonna cut back on our workers. We have 60 people, and now we're only gonna have 40. And the reason is that I'm gonna find more machines, like automatic kiosk, or I'm just gonna cut back and leave dirty tables. Oh, patrons could just clean them themselves, right? Or we used to always be a restaurant that would clean off the tables, but now we're just gonna have a big ass garbage can, and you put your trays here and you dump your own garbage, right? So I can cut labor. So I can come up with other ways to serve my product, which might fundamentally change it, right? If you were used to that service and you like the fact that somebody came and took your tray from me or whatever. But sorry, that's gone. So that's a substitution effect. The output effect then is if there's an increase in wage, the increase in the production cost increases the price. So now I have to pay more money for labor. I wasn't able to get rid of all the people, so my costs went up, which caused my a need to charge higher prices for my pizza. So now I used to charge $20 for my pizza, and now I have to charge $25. And so now consumers, because of that wage increase, and if I put in this would be the supply of pizza, the supply shifter would be S1 and S2. So remember on your list of supply, the price of resources, like wages go up or material prices go up or whatever, the price of resources shifted the supply curve to the left. So that's kind of what we're saying, is that the price of labor is higher now, shifts my supply curve to the left, which means people aren't buying as much pizza. They used to buy 100 and now they're buying 85. And so there's a decrease in output. That decrease in output decreases the quantity of labor that I need to buy anyway. So they kind of work in harmony with each other, with the substitution effect and the output effect, because now I'm making 15 less pizzas, which means I need a half a person less or whatever, or maybe it's 10 less hours or whatever, however we're measuring labor. Okay, questions or comments there? All right, so what causes an increase in labor demand? So that was a movement along the labor demand curve from A to B, but now what causes this thing to move around? What can cause this thing to move around? All right, so an increase in the demand for export goods. So we'll get into that a little bit more with this import-export here in a minute. So just kind of don't worry about that too much, but people want to buy more goods. What else? What else shifts our demand for labor? You're the business now wanting to hire people to make pizza. Maybe you do video games and you do some online selling of hair products in addition to your pizza. I don't know what you do. So, what's that?
Taxes.
Okay, taxes. So taxes, if there's a decrease in the tax rate on labor, good. What else? Yeah, Jonathan?
If demand just increases.
And why, but that's what we want to pin down. Like, why would demand go down? What would cause you as a business? Or now we can think more of the city if we want to and get away from like a specific example like pizza. What would cause people to leave? I'm sorry, not people, these are businesses, and not hiring the people. So taxes was mentioned. New technology. So yeah, if all of a sudden there's a new technology that there's a new pizza machine and I used to have 4 people and now I only need 3, right? So that could change. Yeah. What else?
Higher property costs.
Higher property costs. Okay, so one of the costs of doing business, because this is the business now. All right. So I'm not sure I heard anybody say productivity. What's productivity again? Some of you are starting to get it. Number of output divided by number of inputs. So an increase in productivity. Now these are all things that are going to lead to an increase in the demand curve, labor demand curve, a shift to the right. So we're thinking conceptually of needing more. So if my people become more productive, if labor becomes more productive, they're more valuable to me. I'm able to pay them a higher wage than what I was before if they're more productive. So you guys mentioned taxes, public services. If there's a change in maybe something that I use as part of my business, like the roads or something are in good condition, or a new freeway ramp opens up and I deliver. And so I used to have to always drive 5 miles to the nearest freeway entrance, and now it's right in front of my store, right? Maybe something like that changes. All right, so those are some things I can shift it around. And the whole like freeway thing, that's kind of even with land use policies. What is agglomeration? That new weird word we've been working on for the last 3-4 weeks.
Everybody starts to come together
Everybody comes together, and why?
because it's cheaper and better for.
Okay, cheaper, better, right? So the idea of clustering, that firms want to be in close proximity. What this is saying is that what if the city used to not allow something of new people to enter the market, or things that were complementary to your good, like the button maker when we talked about the dresses in New York? What if something didn't allow button making? Button making required a big factory type setup. I'm totally telling a story here, right? But that factory wasn't allowed to be next to the fashion district. But now they lobbied their politicians, and they were able to get a factory like that set up. That could work to your benefit and increase agglomeration. Okay, so now let's talk about the export thing. So export products sold to people living outside the city. A local product is sold to local residents. How does export employment multiply employment conceptually? So can you give me an example, especially some of you Ottawa natives or people that are closer to Ottawa? Can you think of stuff that is sold, something that's made here in Ottawa that's mostly sold to people outside of Ottawa? Ottawans don't really buy that good very much, or maybe not at all for the most part. Calmar, that's the big one, right? So if you guys, I'm going to show this because you guys need to, I want all of you to have a conception of Calmar, which is now Cargo Tech. I think you can still find them with Calmar too. Cargo Tech, Ottawa, Kansas. Let's see. Just kind of winging it here, so I don't know if I'm gonna get what I want. I want just a picture. There we go. Okay, what are these guys do? Calmar imports. Okay, that's part of one. That's not very. Yeah, there it is, right there. Let's see if I click this. If it's gonna go too much. There. All right. Do you guys see? I feel like I should be able to find. Do you see this? That little weird looking truck. That is made in Ottawa, Kansas. So this little weird truck, see how the cab goes up and then it goes back? So this is used to pull shipping containers around the yard. So it's a specific vehicle that's designed to move those shipping containers, which have become more and more important, right? With intermodal facility, the whole supply chain disruption. By the way, I just talked to somebody off the my buddy that I watched Super Bowl with, he does logistics and stuff, and he said the supply chain backup is still like 107. I can't remember what he said, there was 113 ships at one point, like a month or two ago, and there's still like 107 or 111. That supply chain disruption is not, that's what he kind of started explaining. Like when we had that bottleneck, you can't just say, oh, let's just stay open a little extra hours and like take the relief. He said that's going to take like 9 months or more to get back to, you can only push it so fast to unload that cargo into the port. And so he said it's not even close to being fixed at this point or resolved. So anyway, little old Ottawa, Kansas, that's what they make up there. Now, how many of those do you see driving around town? Back to our talk here. 0, unless you drive up there. So if you go up there, they have a little kind of a course that they used to not have this, but they built a road system. So then when they roll that off the manufacturing plant, they take them for a test drive and make sure that they seem to be working fine before they ship them off. All right, so that is an export product that Ottawa sells. How does the export employment multiply employment in Ottawa? Jameson.
It brings people from like different like cities to
Yeah.
work here.
To work here, yeah. So if we have employees, I don't remember how many, but remember I sent around university-wide that they're dying to have people. So if you're looking for a kind of, they have some internship possibility and they also have like part-time work. And he told me it should be around probably $20 an hour, but he didn't commit that. That's kind of off the record, but like at least 16 it sounded minimum. Somewhere between $16 and $20 an hour. So they have maybe some new people come to Ottawa, and then what do those people do when they're making $60,000 a year?
My house, no.
They buy a house in Ottawa. Where do they go shop? Where do they go eat? Smoke Creations, pizza time, right? They don't go every meal up to Lawrence. Where do they buy the groceries? Walmart Price Chopper, right? So that is that good for Walmart Price Chopper, Pizza Time, Pizza Village, Smoke Creations? Of course. So we got this possibility of multiplying the employment by looking at the export products versus the products that are sold locally. All right, so local products, so related to this multiplier, they're going to spend a portion of their income on local. And then the total employment for the town is going to change by some multiple, in theory, of the person that was hired by Kalmar. So Kalmar hires a person, employment goes up by that one person, but now that one person goes and spends $60,000 on stuff elsewhere, and they create employment for another person working at Pizza Time. All right, questions or comments on the concept? All right, so here's some real world multipliers from a study done in Portland. And here we've got frozen food, wineries, carpet and rugs, footwear, envelope, fiber optics, software, legal, computer systems. I'm just kind of jumping down here, hospitals, spectator sports. So we got all kinds of different industries. And so why do they vary by industry? Why do some multipliers have a 1.5 and others have a 2.17 and 2.14, 2.53? Why do they vary?
Consumer preference.
Consumer preference of what?
Like see like the higher numbers are stuff that people actually get to go out and do rather than just like stuff they have to do.
Okay, so it's a little bit on the demand side of what the consumers want to buy. Okay, what else? What else has the high numbers up there? So 2.71, fiber optic cable manufacturing. That's a high one.
Because they're really great.
High demand, skilled labor. So highly skilled labor means what for money? Good money, right? So that can make a difference too. If it's a $100,000 job versus a $30,000 job. What different types of industries, if they're bringing docs in, for instance, if it's a medical thing, then the doctors might be spending a lot more. Okay, so there's always a mix. And what is the relationship then? The bigger, help figure out this, fill in the blank here. Bigger fraction of export sales leads to a bigger or smaller multiplier. bigger, right? So the more we're bringing in a product that our people aren't buying, so we're bringing in a $100,000 job, we're building a goofy looking truck. Nobody in Ottawa is buying that, including the person who made the truck. And so all that money's being spent more locally, right? So in general, the relationship would be that would be bigger. Okay. So the metro average over all these industries is 2.13. So if you just take all these numbers, average them out, 2.13. How would you interpret that? Interpretation of 2.13. So this is kind of similar to elasticity. You go to your boss and you're like, boss, the multiplier is 2.13. And your boss says, what does that mean? We go, Carlos.
For each one more here that we create here.
Okay, 2.13 for that extra job. So that extra job brings in 2 more jobs?
No.
Or 1 plus, how many more jobs does it bring in? For every 1 job we add 1.13. All right, that's just kind of a little nitty gritty detail here. So every export job, so this is where you're looking at the export jobs, supports 1.13 local jobs. So we've got the export job, and then they spend their money, and it creates another job, on average, 1.13. So a 1 job increase in export employment leads to an increase in total employment of 2.13. All right. Let's see here. I check if we're ready to do a problem yet or not. We're getting close. No, maybe not. Maybe that on a different one. Okay. So we can kind of break the demand shift, which is where we started with this multiplier concept, that there's going to be this extra bump from this export local distinction. So we kind of think of the initial shift being to D2, and then additional demand coming from the kind of the increase in population is one way to think about it, right? Or the income, and so we get that extra bump. So we can think of the total effect being bigger than what it otherwise would. All right. Now, we're going to mix the two. So how can we get this multiplier concept going, but we've also got supply? If there's an increase in demand that causes a multiplier, and so we get the final shift, this is like D3 in here. That was at $10 was the initial wage. The multiplier concept says we go from 60 to 120, just making up some numbers here, which is probably way too large. But what does that miss out on in terms of predicting equilibrium? What is missing off this picture? The supply. And so what's going to happen to wages when there is an increase in demand with the supply taking into account? Down? Right? So if we just throw in any old supply curve here, then instead of going from here to here, which is what the multiplier might suggest, we'd actually have a bump up in wages. All right, so that's the problem with these multiplier studies, is that focuses more on jobs rather than on the income of those jobs, because it's just one, we're counting people, not money. But that is why we saw some of the multipliers higher than others in different industries. But we are still counting just the jobs. And it also is bad, I think, in the sense of the fate of the city is in the hand of the outsiders, right? So, oh, Ottawa's never gonna live unless we find some big corporation to park themselves out on the south side of Ottawa, right? So you start to have, I think, kind of a negative mentality to you're always grasping for somebody to help you. Oh, Ottawa's just little old Ottawa. Population's been what it's going to be. It's not going to do it. Oh, unless maybe somebody came out and helped us, right? A corporation parked themselves. So, you know, that's a little misleading. Like, there's not changes that could be done to Ottawa in other forms. We're not just completely reliant on an outsider coming in to save the day with a big industrial development. Okay, so we have the positive slope with the supply curve. So we've got some things with the model: fixed hours per worker, fixed participation rate, migration in response to wage differences. So we have people moving into Ottawa when the wage comes up. Increase in wage attracts workers, just like we did from chapter 7. Growing cities offer higher wage to offset the costs. And then so they have different elasticity estimates, different studies, and interpret that number. Go ahead and write it down. I'm going to randomly select one of you. I'm going to read off the middle one. I think my pointer did get a little off, but it looks like it's pointing at the middle. So we'll give it a go. This looks like a great thing to have on Friday as a test question to be able to interpret the elasticity. So we got the elasticity of wage and labor force. So back in your notes, if you took careful notes, we did that a couple different times on Friday. I'll give you 1 minute. And then I will randomly select one of you. So dazzle me with your interpretation. It will be somebody hasn't spoken. Or spoke very much. You did one. All right, hand up. Number between 3 and 11. 1, 2, 3, 4, 5, 6. Bryce, heard from you. Jacob. Yeah, we're kind of fighting. Might have something like this. Tyler's sweating it out there. All right, so Jacob says a 20% increase in the wage leads to a 100% increase in the labor force. Just put that sucker up there. Got it. There we go. 20% increase in wage leads to a 100% increase in the labor force. How many people agree with Jacob? Ooh, not seeing much support here. Now, let's see what Tyler did. He simply
I did the same thing, but I did with different numbers, so it's wrong with that.
Right? I'm just gonna take yours.
Mine's right. I literally read back at the notes. Just copied it.
I'm gonna have everybody's notebook up here eventually. So, all right. So here's 2 more. There's Tyler, I think. A 1% increase in wages raises the labor force by 0.2. And Andrew, a 1% increase in industry output leads to an increase in industry output per worker.
Basically just
Okay, how many people agree with one of those?
Can I get it?
Kind of agree with the first one. Let's see, Jason. Give me yours.
Yeah, he has the exclamation point.
Let's take yours, McKenna, let's take yours. Okay, that's fine. Alright, give it to me. My way of making sure you guys are taking some notes and keeping good track. It's okay to be wrong. It's not quite as good to be wrong on Friday, though, I'd like to mention, but it's good to be wrong in class here. All right. I don't remember whose this is, but let me back this up. All right, for every 0.2% change in the wage, there's another worker in the labor force. For every 20-cent change, as in 20 cents, like a 0.2 of a dollar. Okay, just want to make sure 20-cent change in the wage, there's one more worker in the labor force. And then finally, Jameson.
I didn't get it all done.
What is that? This little thing here?
Yeah, I would be like 20% increase in
All right. So, some days with teaching is just so sad. It's so sad. There you go, people. Check yours, pass it around. Okay, so first of all, what's the trick? Jameson started to do the trick I saw on his. What's the trick that kind of lets everything hopefully fall into place?
The equation.
The equation. All right, now this is one thing you have to memorize. What is the equation for the elasticity? Percent change in quantity over the percent change in price. Now this is the price elasticity. This is back to principles class. And then what we learned is we can make an elasticity out of anything. And so this particular elasticity, the middle one, is the elasticity is equal to what goes on top and bottom. The wage and labor force.
the 0.2 wage.
Wage goes on top. Which one goes on top? Which one goes on bottom? Wage on top. So the arguments this is just something you do have to memorize the way the book does it. The first one is the argument on top. The second one's the one on bottom, which is kind of flows nicely, at least top and bottom. So then we've got percentage change in the wage. This is where some of you like, okay, when you got the 20 cents, is it 20 cents? Is it 20? It's always percentages. It's always percentages. And the percentage change in whatever the argument here is, which is the labor force. And we're told that this equals a positive 0.2. Okay, so now you always start with the bottom. Any number can be expressed as a fraction by doing what? Putting it over 1. So that's always the easiest one. I usually like to do 1%. The book does 10% too. So we could also think of this as equivalent to 2 over 10, right? We're moving the decimal place over 2.0. That works too. Now it all just flows. What does the 1 go with? The labor force. So this sucker goes with this sucker, and this sucker goes with this sucker. And so now we just tell a story, and the bottom is what's driving it, right? So that's the usually presumed to be the outside factor that's influencing the decision variable. A 1% increase in the labor force leads to a 0.2% increase, because it's a positive sign, increase in the wage. That's it. It's such a beautiful, easy way to lay out. You just have to memorize the sentence and plug and chug. And you have to remember this trick and which one goes where. So there's a couple little things you got to remember. But now it tells a nice story, right? So if the labor force, which is the growth of your population essentially, right? If the labor force increases by 1%, it leads to a 0.2%. So now when we get into these 0.2, it's like, that's not quite as fun. This is where the 10 kind of comes in handy. So we could say a 10% change in the labor force leads to a 2% change. And that kind of plays nicer, right? 10 to 2. Up by 10%, what is it? 10%, instead of 1%, 0.2%. Either way is fine. Jonathan, question?
I mean, I was just gonna say next time.
That thing?
Yeah.
Okay. Well, we're almost done. Okay, good. So those were some elasticities with migration. So shifting the urban supply curve. What makes that supply curve move? Improving the amenities. So maybe we don't have smog in the city or garbage laying all over the place. So we improve some amenities. What other things would cause people to want to live? Remember, it's the urban supply curve now. What would cause people to want to live in our city? We've gone over this before.
Free stuff like transportation.
Okay, public services, other things?
Like, transportation.
Like there's plenty of groceries around, or you were saying a shortage, I think, right? But whatever, that would be a bad, and that would cause you to not want to live there. Okay, Jonathan?
Low taxes.
Low taxes, so tax rates, right? Holding the amenities constant, or an increase in amenities, holding the tax constant. So we kind of covered these before, and being able to switch. So if there is a bad thing like crime, then we have more police officers, we have whatever. We bump up something to try to deter crime, holding constant taxes, decreasing residential taxes. So property taxes are the local tax. And then those public services, if we make those better, that can make a difference. Okay, so now check out what's happening. We don't go from 100 to 121 like the multiplier said we might, because we've got this increase in the wage. And so ultimately the equilibrium ends up being somewhere in between. And we'll pick up there tomorrow. Mark your calendars, you are getting out early today.
Ooh, ooh.
Okay, so this thing just died, totally.
Well, I don't think it died, it just stopped like running. It just went back to the home screen.
Oh, good, it looks like hopefully most of it was on there.
No, I just watched it back to the home screen. Turn it off.
Is that what it did? Yeah. Oh, I wonder if it's because of that.
So it's growing thing.
Yeah, so Bullet Bandit,
Just anger. You're angry.
there was one today. That was great. We talked about last week. Class. Remember, we didn't talk about it. It was, but we designated it every Tuesday. Well, that's okay, just get in there. It's not that many points. If you should check it in. I think it was, I had to do things for the Bullet Bandit was before class today, right? I thought
You did it today.
Yeah, I thought that
Well,
was.
I had to do date in there.
No, there's.
You sent out an announcement 15 minutes before class, saying it was due before class.
Oh, yeah, that-
Well, if that was wrong, maybe it is Tuesday.